Have you ever stopped to wonder how you get an AI to do something more than just, answer a simple question? How do you teach it a really complex, messy, real-world job? Well, it turns out the secret isn't some crazy new technology. It's actually a powerful, old-school computer science principle, one that you can start using right now to get way better results from any AI.
Right? I mean, we see AI doing all this incredible stuff, and it can feel like magic. But there's this massive gap between a simple chat and, say, managing a global supply chain. It's a messy, multi-step human job. So how do we bridge that gap? How do we turn all that AI potential into real, practical results? Well, the key is to break it down.
All right, so here's our game plan. First, we're going to dig into AI's big complexity problem. Then, we'll introduce the solution. It's called decomposition. We'll look at a real-world case study to see how it works, see how it scales up from tiny tasks to powerful AI agents, and then, this is the best part, we'll show you how to use this exact same idea yourself for way smarter prompting.
Okay, first up, let's really get a handle on the core problem. It's all about trying to get AI to manage the absolute chaos of the real world, which, it turns out, is a lot harder than it looks.
Think about it for a second. A real job, like logistics or real estate, isn't just one single task. No, it's thousands of interconnected decisions that use data from all over the place. Emails, spreadsheets, legacy systems, you name it. There's almost never one single clean source of truth. And this messy reality is exactly where that simple question and answer AI just completely falls apart. It needs a much better approach.
So how in the world do we solve this? Well, the answer comes from a classic fundamental idea in computer science. And for a lot of people, this is the big aha moment. It's called decomposition. Now, that sounds a little academic, I know, but at its core, decomposition is just the process of breaking a big, complex system into smaller, more manageable parts. So instead of trying to build something huge all at once, you're breaking it down to understand it and control it. And listen, this isn't some new AI trick. This is a fundamental principle of all engineering.
My favorite way to think about this is a recipe. You don't just walk into a kitchen and say, cook dinner. That's way too vague. A good recipe gives you decomposed steps. Chop the onions, heat the pan to medium-high, saute for exactly 3 minutes. See? By breaking that complex goal into simple, clear instructions, the outcome becomes reliable and repeatable. This is the exact mindset we need for teaching AI. All right, so theory is great, but let's make this real. We're going to look at a case study from a company called Loop, which uses this very principle to tackle the incredibly messy world of supply chain logistics.
So Loop has to deal with tons of unstructured data from things like invoices and emails. Their solution is something they call an atomic task system. It's brilliant. They break down a huge problem, like processing an entire invoice, into the smallest possible tasks, the atoms of the job, which can then be solved one by one, sometimes by an AI and sometimes by a human expert.
And you can see how their thinking evolved right here. The old way was just one task, find the invoice number. But that was often really ambiguous, so they decomposed it. The new way has 3 much simpler steps. First, just extract all the numbers from the page. Don't worry about what they are. Second, find the label, or the key, right next to each number, and finally classify what type of number it is. Each step is way easier, way more accurate, and it builds on the last one.
And here is where it gets really, really smart. Because those tasks are so small and simple, they can have multiple AIs or even multiple people try to solve the exact same one. An answer is only accepted when they get a consensus. It's a wisdom of the crowds approach that makes the whole system incredibly accurate. And that is only possible because they broke the problem down into these little atomic pieces.
Okay, so we've seen how decomposition works for individual, tiny tasks. Now, let's zoom out and see how this very same principle lets us build something much, much bigger. Autonomous AI agents.
An AI agent? Well, it's the next level up. It doesn't just complete one tiny task, it can actually orchestrate an entire workflow. It can reason, it can act, it can remember the context of what it's doing. And the way we build these incredibly powerful agents is by using that exact same principle of decomposition.
You can really see the huge jump in capability here. A chatbot? It just answers questions. Basic workflow automation? It just follows simple if this then that rules. But a true AI agent, it reasons, it makes decisions, and it manages processes across multiple different systems, all while remembering the context. It's not just an efficiency tool anymore, it's a genuine intelligent execution engine.
To build one of these, you actually have to decompose the job itself. So instead of one giant real estate AI, you create a whole team of digital specialists. You have a lead agent that talks to customers, a valuation agent that crunches market data, a legal agent to review contracts. Each one is a specialist, and then you have a master agent that coordinates them all. It's decomposition, but applied to the AI's roles and responsibilities.
Okay, I know this all might seem really high-level and abstract, but now we're going to bring it right back down to you. Because you can use this exact principle to get dramatically better results from the AI tools you're already using every single day.
Believe it or not, every single time you write a really good, detailed prompt for something like ChatGPT, you are already practicing decomposition. You are essentially acting as that master orchestration agent, breaking down your complex request into a series of clear instructions for the AI to follow. Let's look at a classic example here. The bad prompt is just, write code for a website. The AI has no clue where to even start with that. But look at the good prompt. It breaks it all down. It specifies the goal, a bakery website. It lists the specific elements it wants, a title, an image, a menu. And it even gives constraints, use inline CSS. It's a recipe.
So why does this work so much better? It's because the decomposed prompt gives the AI a structured plan. Instead of one giant, ambiguous request, it has a checklist of smaller, very concrete things it needs to include. This drastically reduces the chance for error and gets you so much closer to the result you actually want.
In this principle, it applies to absolutely everything. A prompt like, tell me about technology, is just way too broad. But a better prompt focuses on a specific aspect, like AI in healthcare, adds constraints like a word count, and asks for specific examples. It's the exact same technique. Break it down.
All right, let's wrap this all up and really think about what this means for the future of how we work with technology.
This is the key takeaway right here. For most of us, our most valuable skill in an AI-powered world isn't going to be building AI models from scratch. It's going to be the uniquely human ability to look at a complex, messy process and break it down into logical, solvable steps that an AI can then execute flawlessly.
And that's the thought I really want to leave you with. We often think of AI skills as being super technical, all about coding and data science. But maybe, just maybe, the most valuable and most human skill of all is just analytical thinking and clear communication, the ability to create a good recipe. So the real question is, what complex problem in your work, or even in your life, are you going to try to decompose first?